Hello friends, so let's start with a new chapter of mathematics called as matrices. So now in this video, I'm going to teach you the definition of a matrix and the different types of matrices. So guys, to understand the definition of a matrix, let's imagine that I have given you few numbers like 2, 3, 4, 8, 9 and 6. And if I ask you to rearrange these numbers equally in rows and columns, so how will you arrange? So maybe some of you will arrange like this: 2, 3, 4 in first row, 8, 9, 6 in the second row. So what you did here is you divided these 6 elements into 2 rows and each row has equal number of elements. Or I can say you have divided these numbers into 3 columns and each column has equal number of elements. Maybe one of you can make this matrix as 2, 3, 4, 8, 9, 6. So this is the arrangement. So it means you have divided these 6 numbers into columns equally or 3 rows equally. So these are the different arrangement possible, or you may say that I'll arrange all the 6 elements in a single row or in a single column. So these are the different arrangements that you'll do. So matrix is nothing but arrangement of elements. So let's see the definition. So the arrangement of m into n numbers of elements into m horizontal rows and n vertical columns enclosed within a pair of brackets is called as matrix of the order m into n. Now guys, mn number of elements. So here I had taken 6 elements. Now guys, these 6 elements is nothing but your mn. So when you arrange it in m number of rows and n number of columns, so here what you did, you divided this in 2 rows. So m is 2 and n is 3. Similarly here m is 3 and n is 2. So what we are doing here is this matrix will be denoted as 2 by 3 because the elements which I have given you, you have divided this in 2 rows and 3 columns. So 2 by 3 becomes the order. Similarly here the 3 by 2 becomes the order. So let's see the definition again. So as per the definition, matrix of order m into n has m horizontal rows and n vertical columns, and the order is given by m into n. So always remember, we first write number of rows and then the number of columns. Now normally a matrix is denoted by a capital letter like A, B, C and all, and its elements are generally denoted by A11, A12 or B11, B12 and so on. So we call it as Aij and Bij, where I is the row number, J is the column number. So let's say if I want to show element at this position, so this is the position of second row and the first column. So this is the row number 1, this is row number 2, 3, 4 and 5. Similarly, this is column number 1, 2 and so on. Now if I consider the position of A21, it is second row and the first column. So that is why you can say the name, that is why you can see the name is given as A21. So in A21, this 2 denotes the row number and 1 denotes the column number. Now here you can see that we have Aij. It means I is the row number and J is the column number. So similarly, we denote the different matrices. Now guys, if I ask you what is the difference between a matrix and a determinant. So the major difference between a matrix and the determinant is, in the case of determinant, we must have equal number of rows and equal number of columns. It means the given matrix has to be a square matrix. But in case of a matrix, it can have any number of rows and any number of columns. So this is a major difference. Now, what is determinant? Determinant is nothing but a value of a matrix. So let's say if I want to find out determinant of a matrix, let's say I'm considering a matrix A with element 2, 3, 4 and 5. So the determinant is shown by two vertical lines, 2, 3, 4, 5. So this is how we find out the determinant of any matrix. So this will be called a determinant of A. So guys, this is the difference between the matrix and the determinant. Now let's move ahead with the types of matrices, because I'm sure in the lower standards you have learned how to find out the determinant of a matrix. So now let's move to the next part. So to start with the types of matrices, I'll start with a row matrix. So what is row matrix? So any matrix which has only one row, it means a single row, is called as a row matrix. Now you can see examples on the screen. So I have first matrix with element 2 and 5 and other as element 1, 2, 3. So both matrices have single row. But if you see the column, in the first matrix there are two columns and in the second matrix there are three columns. So a row matrix is a matrix which has one row. Now, what is column matrix? So similarly, any matrix which has a single column is called as a column matrix. Now guys, a column matrix is also called as a vector, and we'll see this when we'll learn the concept of linearly dependent and independent vectors. So a column matrix is also called as a vector. So you can see on the screen, I have a column matrix with two elements 0 and 0. So it has only single column but two number of rows. So this is a column matrix. Now let's see a zero matrix or a null matrix. So any matrix which has all elements as 0 is called a zero matrix or null matrix. And guys, a null matrix is denoted by a spacious symbol called as O. So you can consider examples. So in the first matrix there are two elements all 0. Second matrix has three elements all 0 and third matrix has four elements all zeros. So these three are the null matrices. Now there is one more property about null matrix. Here I have noted that. So A into O. Now A is any random matrix or any random non-zero matrix and O is a null matrix. So whenever you pre-multiply or post-multiply any given matrix by a null matrix, then the resultant is always a null matrix. So guys, it is similar to that of your algebraic things. So whenever we multiply any number by 0, we get 0. Similarly, whenever you multiply any matrix with a null matrix, you get answer as a null matrix. Now let's see the fourth matrix. So that is rectangular matrix. So any matrix in which the number of rows are not equal to number of columns is called as rectangular matrix. So on the screen, the first matrix has 2 rows and 3 columns. So the order is like 2 into 3. And in the second matrix, the order is 3 by 2 or 3 into 2. So number of rows are 3, number of columns 2. Now, if you observe these two matrices, then rows and columns or number of rows and number of columns are different. So such matrices are called as rectangular matrices. Next, a square matrix. Now it resembles to the definition of square. So guys, same thing in the rectangle. So we have seen rectangle in the school days. So rectangle has 4 sides and 2 sides are different. Similarly, in a square, all 4 sides are equal. And that is why in a square matrix, the number of rows and number of columns are always equal. Now you can see two examples. One matrix with order 2 by 2, another as order 3 by 3. So number of rows and number of columns are equal. Now let's see some important note on these matrices. So there is a concept called as trace of a matrix. Now what is trace of a matrix? So in a square matrix, if you take sum of leading diagonal elements. Now what are the elements of leading diagonal? So guys, let's come here. So here you can see the elements 1, 5, 9. So this is a diagonal of a square. So let's say if I draw a square here, there are two diagonals that we get. So this diagonal is called as the primary diagonal or principal diagonal or leading diagonal. So elements on this leading diagonal. So you can see the elements are 1, 5, 9. Similarly here 1 and 4. Now trace of a matrix is nothing but sum of the leading diagonal elements. So that gives us the trace. So we can easily find out the trace of any matrix by just adding the elements along the leading diagonal. Next note, determinant of a square matrix. So the determinant obtained by taking the corresponding elements of a square matrix is called as a determinant of a square matrix. So guys, I've already explained you this when we discussed the definition of a matrix. So to find out the determinant, we should have a square matrix. For a rectangular matrix, we cannot find out the determinant. So that is the thing. Now let's move to the next matrix. So what is diagonal matrix? So I would say a diagonal matrix is a subset of a square matrix. So it's a type of a square matrix only. So it means it will have equal number of rows and columns. So any square matrix whose non-diagonal elements are zeros is called as diagonal matrix. You can see the example in both the matrices. The leading diagonal elements are non-zero, whereas the non-diagonal elements are zeros. So such matrix is called as diagonal matrix. Now guys, let's learn how to represent a diagonal matrix. So a diagonal matrix having the diagonal elements as d1, d2, d3 can be represented as A equal to diagonal in bracket the elements along the diagonal. So here I can say that this A is equal to diagonal matrix. So in bracket 1, 2. So this itself shows that it's a diagonal matrix. Now let's see the next matrix, that is scalar matrix. So guys, this scalar matrix and diagonal matrix look similar. So here also the non-diagonal elements are 0. But if you observe the diagonal elements carefully, then they are equal. So it means I can say that a scalar matrix is a subset of a diagonal matrix. It means it is kind of a diagonal matrix only with a condition that all elements has to be same. So that's a scalar matrix. Now, what is unit matrix, which is also called as identity matrix? So let's say in a scalar matrix, right now we have elements as 4, 4 and 4. So instead of 4, 4 and 4, if we write all elements as 1, 1 and 1, so it will look as a unit matrix or the identity matrix. So if all elements of the leading diagonal of a scalar matrix are 1, then it is called as unit or identity matrix. Now guys, identity matrix is normally denoted by capital I. And if you find out the determinant of the unit matrix or the identity matrix, it is 1. So these are the two things that you have to remember. Also, if you multiply any given matrix with the identity matrix, then you get the same matrix again. So A into I or I into A will give you A again. So these are the things which you have to remember for a unit matrix. Now, the ninth matrix is a upper triangular matrix. So the definition says if the element below the leading diagonal. So here the leading diagonal is this 1, 4, and here the elements are -1, 0 and 5. So elements below leading diagonal. If all these elements are 0, then such matrix is called as upper triangular matrix. Now guys, how you can remember this is when we say upper triangular, it means elements above the leading diagonal should be non-zero. This is how you have to remember. Now lower triangular, reverse case. So whenever we see the elements below the leading diagonal and if all elements are non-zero, or in other language if I say the elements above the leading, or in other language I'll say if the elements above the leading diagonal of a square matrix are all zeros, then such matrix is called as lower triangular matrix. So it is very simple to identify between upper triangular and lower triangular matrix. Now let's see the next matrix, which is transpose of a matrix. Now to understand transpose of a matrix, here you can see the example. So let's say there is a matrix A which has 12 elements, and those 12 elements are represented in 3 rows and 4 columns. So I would say the order is 3 by 4. So the transpose of a matrix is normally denoted by A dash or A T. Here I'll write A T or A dash. So here I'll give the dash. So transpose is normally obtained by interchanging the rows and columns of a given matrix. So you can see here we have first row with elements as -2, 3, 4, 5. If I interchange first row with first column, then these elements will come in the first column. So here we got the element -2, 3, 4 and 5. Similarly, second row has -1, -2, -3, 4. Here we got -1, -2, -3 and +4. So the element in the second row shifted to the second column. Now in the third row we have 0, 1, 2, 3 and those got shifted to third column. So we have interchanged the 3 rows to 3 columns and we got the transpose. Now if you see the order of a transpose matrix, then it is exactly reverse of the order of a normal matrix. So it is 4 by 3. So our matrix had the order as 3 by 4 and now here we got 4 by 3. Now guys, let's see some properties of transpose of a matrix. So the first property is A dash and dash. It means if I take transpose of a transpose matrix, then I get the original matrix back. So it's very simple. Guys, you can see here the A has order 3 by 4. A dash has order as 4 by 3. And if I again find the transpose, it will be 3 by 4, which is same as the original matrix. So transpose of a transpose matrix is the original matrix. Next, if I find AB dash or transpose of a matrix A into B, then it is equivalent to B dash A dash. That is a multiplication of B transpose and A transpose. Now to understand this property, you may take any two matrices. You may label it as A and B with same order. Then multiply it, find out AB, take transpose of that matrix. So you got the left hand side. Now for that A and B, find out transpose individually and then multiply B dash with the A dash and get the answer. And you will find that both the values are same. And we have done such type of examples when we were in the 11th and 12th standard. So I'm not covering those things over here. Now next property, if you try to find out the determinant of transpose matrix, then it is always equal to the original matrix A. But guys, this case is applicable if and only if the given matrix is a square matrix. Because for rectangular matrix, we cannot find out the determinant of the given matrix. So guys, these are the three properties. Now let's see the next matrix, that is the conjugate of a matrix. So guys, to find out the conjugate of a matrix, it is always denoted by A bar. So here I'll write it again, A bar. So this horizontal line is called as bar. So when we find out conjugate of a matrix, what we do is we find out the conjugate of the elements of that matrix. So here you can see that we have a matrix A. Now if you observe the matrix A bar or the conjugate of the given matrix, then see the element -2 is same as -2, but element 1 plus I had changed to 1 minus I. So we got the conjugate of 1 plus I. Now we have learned this in the complex number. So this is also called as complex conjugate. Now the conjugate of 2 plus 3i is 2 minus 3i. For 2i the conjugate is -2i. For 0 and 4 it will be same. For 1 plus 4i it is 1 minus 4i. For minus I it is I. and for 3 plus 2i it is 3 minus 2i. So we have taken the complex conjugate of each and every element and we got the conjugate matrix. So it's very simple. Now let's see the transpose conjugate. It means the matrix number 11 and the matrix number 12 will merge it. So in 11 we learn how to find out transpose, in 12 we learn how to find out conjugate. Now we learn how to find out transpose conjugate of a matrix. Now guys, transpose conjugate is nothing but conjugate of a transpose matrix. So in both ways you will get the same value. So it is generally denoted by A star or A theta. So as name suggests, what we have to do is we have to first take conjugate and then transpose, or vice versa. So here you can see, so what I'm doing is I'm taking the example which we have taken for the conjugate of a matrix. Now let's find out the transpose conjugate. Now guys, see, for the above matrix A we already got the conjugate. Now I'll just take transpose of that. So if I take transpose, so A bar is there, I'm just taking the transpose of that, and guys this is nothing but A star or A theta. So let's see what will be the transpose of that matrix. So first row, so to find out the transpose we interchange row with column. So the first row is minus 2, 1 minus I and 2 minus 3i. So that will become first column. So minus 2, 1 minus I and 2 minus 3i. Similarly, this is the second row which is minus 2i 0, 4. So here I'll write minus 2i 0 and 4. That will become my second column. Here the third row is 1 minus 4i and 3 minus 2i. That will become my third column. So 1 minus 4i and 3 minus 2i. Now guys, if you observe this matrix and this matrix, it is exactly same. So we got the transpose conjugate of a given matrix. Now guys, this transpose conjugate will be useful when we learn the concept of Hermitian and skew Hermitian matrix. Now let's move to the second last matrix, that is a singular matrix. So any square matrix whose determinant is 0. So whenever we find out the determinant and if we get the value of the determinant as 0, such matrix is called as singular matrix. For example, this matrix. So here element as 2, 6, 1, 3. I find the determinant. So when we multiply the elements on the leading diagonal with the elements on the secondary diagonal, so 2 into 3, 6, minus 6 will get 0. Now similarly, the last matrix, that is non-singular matrix. So any square matrix whose determinant is not 0 is called as non-singular matrix. So there is one matrix A with element 1, 2, 3, 4. When we find the determinant, the value is minus 2, which is not equal to 0, and that is why the given matrix is non-singular matrix. So guys, here we have covered different types of matrices. Yes, there are certain special matrices like symmetric matrix, skew symmetric matrix, Hermitian matrix, skew Hermitian matrix, or nilpotent matrix. So such type of matrices we'll see in the next video. So guys, I'm sure you understood the definition of a matrix and what are the different types of matrices. And this we are going to use while solving the different examples. Thank you very much.